Hey guys, Miss Fearon here. Welcome to Unit 8, Note 7. Today we're going to go ahead and talk about the distance formula. So our distance formula is a formula we use to calculate the distance between 2 points. And it looks like this. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's going to equal the distance then. So let's just look at a couple problems and jump right into practicing it. We want to find the distance between the points given. If necessary, write your answer as a simplified radical. So let's look at number 1 here. I have 2 points. I have an x and a y and an x and a y. So I'm going to plug that into my distance formula. So I know the distance equals the square root of x2, so I'm going to do 11, minus x1, 5, squared, plus y2, 7, minus y1, well, it's a negative 1, so we can chop that, squared. So we're going to simplify a little bit here. I'm going to do the square root. 11 minus 5 gives me 6 squared, plus 7 plus 11 is going to give me 8 squared. Simplify again. I'm going to get the square root of 36 plus 64. Even further, I'm going to get the square root of 100. If I plug that into my calculator, it does give me a nice number, so I know that my distance is going to equal 10. Number 2 then, again, I have 2 points, so I have my x and my y, my x and my y. We're going to plug it right into the distance formula, so I'm going to get distance equals the square root of x2 minus x1 squared. So I have a minus and negative, I can chop that, plus y2 minus y1 squared. Simplify this a little bit, I get the square root. 4 plus 4 is going to give me 8 squared. 17 minus 2 is going to give me 15 squared. So 8 squared I know is 64. 15 squared I know is 225. So I'm going to get the 64 plus 225. I'm going to be taking the square root of 289. So my distance is going to equal 17. Number 3, x and y. Plug that into our distance formula. So I'm going to get negative 4 minus 2 squared plus 6 minus 3 squared. So when I get to a negative 2 minus 2, I'm getting even more negative, so I have a negative 6 squared plus 6 minus 3 is going to give me 3 squared. So negative 6 squared, make sure you plug that into your calculator with the parentheses around it. A negative 6 times a negative 6 gives me a positive 36 plus 9. So I'm going to get the distance equals the square root of 45. Now, when I plug that into my calculator, I get a decimal, and it tells me to write my answers in simplified radical. So a decimal is not okay. I got to see if I can simplify this radical. So if we think back, we remember that to simplify radicals, we need to rewrite it so that we're timesing a perfect square times something else to get back to 45. So I know that I can take the perfect square of 9 times 5. So my distance, square root of 9 is 3. Square root of 5 is a decimal, so we can't do it, so we would leave it that way. I want you to pause the video here and try number 4 on your own, then come back and check your answer. When I did this work, I got the distance equal to 2 times the square root of 13. If you got anything different, please come chat with me before moving on to the rest of the video. So number 5 here, we're looking at Tracy's golf ball that is 20 feet short and 8 feet to the right of the cup. On her first putt, the ball lands 2 feet to the left and 3 feet beyond the cup. If the ball went in a straight line, how far did it go? So I'm going to draw myself a picture here. Here's the cup. So her golf ball started 20 feet short, so 20 feet below it, and 8 feet to the right of it. So here was her ball when it started. If we are thinking of this as a coordinate plane, and this was the origin, we can create this as a point. I went negative 20 in the y direction and positive 8 in the x direction. So her ball was at the coordinate point 8, negative 20. Now, after her first putt, the ball lands 2 feet to the left. So it went to the left 2 feet. And then 3 feet beyond the cup. So 3 feet beyond the cup. So if I wanted to create that as a coordinate point, her ball was right there after the putt. She went negative 2 in the x direction and 3 in the y direction. So the question is asking us, if it went in a straight line, how far did it go? Okay, so if it went this way, how far did it go? So we're going to use the distance formula using our 2 points. I have an x and a y. So example number 6, on her college campus, Kelly has her first class in Rhodes Hall and her second class in Fulton Lab. How far does she have to walk between her first and second class? So we're going to go ahead and look at this campus map here. She's going from Rhodes to Fulton. So she's going right there. So we need to figure out, using all of this, we need to figure out how far she would have gone in one direction if we were to go in a straight line and then another in the straight line this way. So to do that, I know that from here to here, it's 1/4 mile. And she then went an extra this way to get to Fulton Lab, a 1/8. So I am actually doing the 1/4 plus the 1/8 to figure out how long this side is right here. So that side's going to end up being 3/8 long. So if she was going to walk in some straight lines, was going to go 3/8 to the right, 3/8 of a mile to the right, and then she would just go straight down, which I know this distance as being 3/8 as well. So if you're looking at your picture, you're kind of looking like this is a right triangle. And if you think back to Pythagorean theorem, we can go ahead and we can use that since we're dealing with a right triangle. So we're going to use Pythagorean theorem here. We're going to get our a squared. Well, a is this first distance that I went here, right here, which is 3/8 squared, plus our b squared. Well, that's how much she went down, so that's going to be 3/8 squared. And that's going to give us, if she were to walk in that straight line, how much it would have been. So when you are squaring a fraction, you're going to square the top and you're going to square the bottom. So 3 squared is going to give me 9, 8 squared is going to give me 64. So I'm going to get 9 over 64 plus 9 over 64 is going to equal c squared. So I'm going to go ahead and I am going to add these together. The denominators are already the same, so they're going to stay the same. So I'm getting 18 over 64 equal to c squared. We know that we have to square root. And remember your quotient rule that says I can take the square root of the top divided by the square root of the bottom. So when I do that, I'm going to end up getting the square root of 18. Square root of 64 is 8. And it then, if I go ahead and simplify this in my calculator, it tells me that she would walk 0.53 miles. So if she walked from one to the other in a straight line, she would walk 0.53 miles. You could have reduced this into a simplified version of a radical, but because it doesn't tell us we have to do that, you didn't need to. You can give me a decimal as your answer. So you may be asking, well, why did we just use the Pythagorean theorem in the distance formula notes? So let's go ahead and see how they're kind of connected here. I'm going to pick 2 random points. I'm going to pick 0.51 and 0.27. Okay, so those are my points. So the distance formula, we would just want to go straight from one point to the other. But when you're on a coordinate grid, we can't just do that. We can't just add little boxes because we're not actually going on the sides of the boxes. We're cutting through. But we can use the long way around. So we could go this direction, which is 3 units. And I know that because I did 5 minus 2. So I did my x2 minus my x1. And then we could go this way, which is going to be 6 units, which is going to tell me my y2 minus my y1. So we can look at this and see Well, technically, a squared plus b squared equals c squared. That's my Pythagorean theorem. Well, I know a is going to be 3, and I know b is going to be 6. And that's going to equal c squared. Well, 3 was actually the x2 minus x1. I'm going to go ahead and write this down here. That was actually my x2 minus x1 squared. And the 6 was actually the y2 minus the y1 squared. And that's going to equal c squared. Well, to solve for c, we know that we just take the square root. And there is my distance formula. So technically, we're using the same kind of idea. The distance formula and the Pythagorean theorem are very closely connected. So we're going to look at this last example for today. We want to find the possible values of a if the distance between the points 7, 5 and a negative 3 is 10. So we're going to use our distance formula knowing that our distance is already 10. So here's my distance formula, and we're going to plug in some things that we know, or that we do know. Plus y2 minus y1. All right, so I know my distance is 10, so that's going to go in for distance. I know that my x2 is a, and my x1 is 7, so a minus 7 squared, plus my y2 is negative 3 minus 5 squared. So we're going to go in and we're going to simplify what we can. I cannot simplify the a minus 7 because I don't know what a is. So we're going to leave that as a minus 7 squared. When I do negative 3 and negative 5, I get negative 8 squared. Extra step to simplify. Again, I still don't know a minus 7, so we're going to leave that as a minus 7 squared plus 64. So now we're going to try to solve this thing for a. So think back. We want to solve, we're going to get rid of the radical. So to get rid of the radical, we need to square. What we do to one side, we have to do the other. So I'm going to get 100 is going to equal a minus 7 squared plus 64. So we're going to finish solving for a now. We always got to get rid of the adding and subtracting first, so we're going to subtract 64. I'm going to end up with 36 equals a minus 7 squared. To undo a square, we take a square root. So I'm going to get 6 equals a minus 7. And now we just have to add 7 to both sides. So I know that a is going to equal 13. Your next step is going to be working on the assignment for the day. If you have any questions, come chat with me before moving on.